lecture we are introduce topic number 1, unit and measurement. The weightage of this topic is a 5 mass. Already the name mentioned that unit and measurement. In this topic we want to study about the measurement and their units. Okay. In introduction, what is physics? First of all, we will see our surrounding. We conclude that there are so many things which are measured in different ways. The measurement is expressed in a particular standard that is called as a units. So physics is a branch of science which deals nature and natural phenomena. In physics, we will study about the properties of matter, laws acting on these properties, the different phenomenon involved for the study of physics. We have to use different quantities. These quantities are called as a physical quantity. So what is meant by the physical quantity? The quantities which are measurable, countable, these are called as a physical quantities, and then we can express in particular standard or units. Next we will see the basic the physics is based on the measurement. In this chapter we are going to detail study about unit and measurement. We will see one by one. So need of measurement in engineering and science. In everyday activities we require a measurement. Sometimes if I want to measure the how much capacity of that container, so we will express in liter, mls. If the length of that pen, so what is the length of that pen in centimeter, inches, mm, okay, diameter of that. So in this way we require the measurement in engineering and science. The measurement of a given quantity is defined as the act or result of the quantitative comparison between an unknown quantity and predefined standard unit. Suppose I want to measure the length of that pen. It is a 0.5 meter. So how I can express that is 0.5, because 1 meter is the standard predefined and the length of that pen is what? Unknown. So by using the standard unit we are measuring the length of that pen, so that is the 0.5 meter. Second, the measurement of the quantity plays an important role not in a day-to-day life but also in all branches of engineering and the science. Day-to-day life we are measuring so many things. Weightage of the gold, weightage of the vegetables, weightage of the iron and so on. Similarly, we can also take the reading like the current, voltage, power, speed and so on. For that quantity we require a measurement. There are basically two main requirements of the measurements, which are this: standard used for the comparison purpose must be accurately defined and should be commonly accepted. It means what? Suppose I want to measure the mass of the object. It is easily comparable and commonly acceptable. If someone says that I am not agree with that measurement, I want my own system, so we should avoid that conflicts. So that's why the system should be what? Commonly acceptable. Next, the apparatus used for and procedure developed must be provable. So whatever may be the apparatus we are using for the measurement of that quantity, physical quantity, so that will be what? Provable and well developed. Next, need of measurement. It means next part. Every measurement needs two main things. Which are these two? First one, number and standard. So how it is important? We'll see. First, number. Example we are taking. For measuring the length of the quantity, the standard taken is as 1 meter. As I already explained, pen. Okay. So the standard is what? 1 meter. In this example, the number indicates the magnitude of that quantity and meter indicates the standard of that quantity. Okay. So 1 is what? Just number, and meter is what? Standard or the unit. Next, we are taking the second example. For measuring the electric current of the quantity, the standard taken is as 5 ampere. It means what? The device which is indicated, that is called as a ammeter, which is indicating the 5. 5 is what? The quantity, number, and 5 ampere is what? Standard. It means what? The current which is flowing to the ammeter is 5 ampere. Okay? I hope that you are able to understand. In this example, number indicates magnitude of that quantity and ampere indicates standard of the quantity. That is what? Electric current. Next, we will see definition of the unit. How we can define a unit? Unit, it is defined as the standard used for the measurement of the physical quantity. Okay? Example, 25 kg. So 25 is what? That is magnitude, that is number. Kg is what? Unit, standard. Here the 25 is the magnitude of that quantity. Kg is the standard to measure the quantity of the body. In this case, the mass of the body is 25 times greater than the standard unit. The unit of the mass was just kilogram, and I have the body having the mass is what? 25 kg. So kg, that is the standard unit, and 25 it is the magnitude. So when we are comparing with the standard unit, so that mass of the body is 25 times greater than the standard units. I hope that you are able to understand. Next, we will see definition of the physical quantities. What is a physical quantity? Physical quantity is defined as the quantity which is able to measure or quantifiable. It means countable. Example, length, mass, time, area, density, velocity, acceleration, momentum, impulse, pressure, and so on. Physical quantities are classified as fundamental physical quantities, derived physical quantities, and last but not least, that is supplementary physical quantities. We will see one by one. What is a fundamental physical quantities? Fundamental, it is what? Basic. The physical quantity which do not depend upon any other quantity for their measurement are called as a fundamental quantities. It means what? These quantity are independent, जिसे किसी दूसरे के ऊपर डिपेंड होने की जरूरत नहीं होती है, वो क्वांटिटी को कहा जाता है फंडामेंटल फिजिकल क्वांटिटीज. Okay. Now, which are these fundamental physical quantities? These are the 7 quantities. We will see one by one. L, that is length, mass, time, temperature, electric current, luminous intensity, amount of the substance. Okay. So these are the 7 fundamental physical quantities. The abbreviation of these 7 fundamental physical quantity is nothing but the LMTELA. Okay, here in this screen, these letters, the 7 fundamental quantities, first letter is bold, okay, and underline. So each letter we are taking, first letter we are taking, and the abbreviation is nothing but the LMTELA. A stand by the length, M mass, T time, T temperature, electric current, L luminous intensity, and the last one is the amount of substances. Okay, so that is what LMTELA. Next we will see units and symbols of this 7 fundamental quantity. Length, it is expressed in the standard unit, that is meter, symbol small m, mass kilogram, kg, time second, s, temperature Kelvin, capital K, electric current ampere, capital A, luminous intensity candela, C, D, last one amount of the substances mole, MOLE, and the symbol is what? MOL, mole. Okay, so these are the 7 fundamental physical quantities which are their units and symbols. Okay, I hope that you are able to understand. Next we will see derived physical quantity. The word derived, it means what? We can determine something that, okay, so derived quantities are the physical quantities which depend upon other quantities for their measurement are called as a derived physical quantity. It means what? They are depend more than one fundamental quantities. We will see one by one. Example, that is area, force, density, speed, volume, charge, momentum, impulse, pressure, acceleration, and so on. Okay, so area is what is meant by the area? Area is nothing. Suppose I want to determine the area of the board. Okay, so area is nothing but a length into breadth. So what is that? More than one fundamental quantity. Length into length, that is what? Length into length, that is what? Length square. So unit of the length is what? Meter into meter, that is what? Square meter. Sometimes we can express in a square meter, or sometimes we can meter square. Okay, so how we can represent here? Meter square. The question mark is regarding what? How we can express. Okay, that is what? Meter square. Volume is what? If I want to determine the volume of the cubical body. Okay, suppose I have a duster. Okay, it having the 3 dimension, length, breadth, and the height. Okay, so length meter, breadth meter, and height is what? Also in meter. So cubic meter or meter cubic. So it is what? Symbolically m superscript t. It means what? M cube. Third one, acceleration. Acceleration is nothing but that rate of change of velocity with respect to time. Okay, so that's why meter per second square. Okay, meter oblique s square. Okay, we can express symbolically. Fourth one, force, newtons. Okay, symbolically it is expressed in a newton. It also expressed in another way. Okay, that is, what is that? Kg meter per second. Okay, next, pressure, Newton per square meter, that is Newton per meter square. Here that m square, that is superscript. Okay, 6th one, viscosity, Newton second per square meter, ns per meter square, and so on. It means density, kg per cubic meter cube, velocity meter per second, angular velocity radian per second.